Okay, Assalamualaikum and very good morning to everyone. So, welcome back to another video for chapter 4, chemical bonding. Okay, in this lesson, which is lesson 3, we're going to cover two subtopics, which are exception to octet rule and also the resonance structure. Okay, so by the end of this lesson, okay, you should be able to explain the exception to octet rule. Okay, we have three different exceptions. The first one which incomplete octet, the second one expanded octet, and the last one is the odd number electron. So the second learning outcome for this lesson is you should be able to illustrate the concept of resonance by using an appropriate example. So we're going to start with the exception to octet rule. Okay, octet rule ini adalah one of the golden rule that we apply to determine the bonding between the atom. However, the octet rule does not applicable for all elements. There are certain elements that does not obey the octet rule. Okay, so because octet rule, if we do the experiment for the certain molecule, it does dia takkan follow for octet rule. Maknanya if the number of the electron surrounding the atom tak cukup 8 pun, elemen compound itu dah dikira sebagai stable. So kita akan discuss lah three different type of exception for octet rule. Okay, so we have incomplete octet. Okay, incomplete octet, that means the total number of the valence electron surrounding the central atom must less than 8. So dia mesti even number tapi dia less than 8. So for example 4 and 6 lah normally. Okay, for expand octet, so expand octet, the total number of the valence electron surrounding the central atom must be greater than 8. So for example, 10, 12, 14 and so on. And the last type of exception to octet rule is the odd number electron. So the odd number electron is happen when the total number of the valence electron on the central atom for a stable molecule is odd number. So for example, 3, 5, 7 and so on. So we're going to discuss incomplete octet first. Okay, macam saya kata tadi, incomplete octet happen when the number of the electron surrounding the central atom in a stable molecule is less than 8. So normally adalah either 4 ataupun 6 electron. Okay, so incomplete octet can only happen if the central atom consists of one from these three elements. Okay, so if the central atom is either made up of boron, beryllium or aluminium, baru dia boleh dapat incomplete octet. Maknanya the number of valence electron surrounding the central atom itu mesti less than 8. Tapi syarat dia central atom itu mesti either boron, beryllium ataupun aluminium. So, we take a look at the first example. So, let's say kalau saya ada BF3. So, BF3, if you draw the Lewis structure of BF3, the boron will become the central atom. So, the boron will become the central atom and the fluorine will become the terminal atom. So, this is the Lewis structure for BF3. And if you calculate, so if you calculate the formal charge for each of the atom in BF3, awak akan dapat fluorine ini sama dengan 0, formal charge. This fluorine is also equal to 0, this one 0 and this one also equal to 0. So macam kita belajar from the previous lesson, if each of the atom in the molecule have formal charge equal to 0, that means the molecule is a stable molecule. Okay, kalaulah awak nak octetkan juga boron tu, okay, kalaulah awak nak octetkan boron itu, so kita akan form double bond between one of the fluorine with boron. So let's say kalau saya formkan double bond dekat fluorine yang ini, okay, awak cuba calculate the formal charge for each atom. Okay, so awak calculate the formal charge. Okay, so this fluorine awak akan dapat 0. This one awak akan dapat 0. Okay, this boron awak akan dapat minus 1 and this fluorine. So 7 minus 4 plus 2, 6 awak akan dapat positive 1. So if you compare the formal charge between these two structure, awak akan tengok yang structure ini adalah structure yang paling stabil. Even though the central atom does not have 8 electron. So that's why lah kita panggil ini sebagai incomplete octet. Sebab kalau awak kira the total valence electron surrounding the boron, we only have 2, 4 and 6 electron. Even dia tak cukup 8 pun, tapi kalau kita kira dia punya formal charge itu dia masih stable. Okay, so second example is BeCl2, beryllium chloride. So beryllium, so ini structure dia, okay, kalau awak lukis dia punya Lewis structure, okay, awak akan dapat macam ni dia punya Lewis structure. Okay, if you calculate the formal charge for each of the atom in the beryllium chloride, this one awak akan dapat 0, this one awak akan dapat 0, this one also awak akan dapat 0, which is stable kalau kita consider dia punya formal charge. Even though the total number of valence electron dia tak cukup 8, which is for this case, for beryllium, this beryllium, the total valence electron surrounding the central atom is equals to 4 electron. Okay, so the last one, kalau for example, kalau saya ada AlCl3. So AlCl3, if you draw the Lewis structure, the aluminium will become the central atom. And then the chlorine, okay, the chlorine will become the terminal atom. So again, calculate the formal charge for each of the atom. So chlorine, this one 0, 0, 0, and this aluminium also 0. So if you consider the formal charge, this structure atau this Lewis structure is the stable one, even though this does not have octet configuration on the central atom. So remember, in complete octet, when the total number of valence electrons surrounding the central atom less than 8, less than 8, dan itu kita panggil incomplete octet. Dia ada 3 je elemen. So kalau central atom tu either boron, beryllium ataupun aluminium, dia mesti incomplete octet. Okay, the next exception to octet rule is the expanded octet. So expanded octet ini happen when the total number of the valence electron surrounding the central atom in a stable molecule is greater than 8. So 10, 12, 14 and etc. So normally until 12 je lah, sebab if I'm not mistaken tak ada lagi elemen yang boleh form 7 bond. Okay, if I'm not mistaken lah. So saya tak sure. Okay, so then expanded octet ni normally happen for a non-metal. So when the non-metal become the central atom and the non-metal is located in period 3 or higher. Okay, reason ni sebab apa? Sebab kalau period 3, okay, kalau kita tengok kalau n, kalau period 3, that mean the highest quantum number is n equal to 3. So when n equals to 3, the possible number of L is 0, 1 and 2. So maknanya dia boleh either S orbital, P orbital or D orbital. So if the element are located in period 3 or and above, okay, there is empty D orbital dalam tu. So the empty D orbital tu yang membolehkan kita masukkan extra elektron tu. That's why dia boleh dapat valence elektron lebih daripada 8. Sebab apa? Sebab in element in period 3 and above, dia ada empty D orbital. They available for to accommodate the extra electron. Okay, so kita tengok contoh. So PCl5. So for example, it's PCl5. So if you draw the Lewis structure, the phosphorus will become the central atom. So phosphorus akan become central atom. So this one, so the terminal atom is the chlorine. Okay. So this kita octetkan terminal atom. So kalau awak kira formal charge, so if you calculate the formal charge, this chlorine 0, 0, 0, 0, 0 and the phosphorus also 0. Okay, kenapa saya kat tadi phosphorus dia boleh form expanded? Okay, kita tengok the electron configuration phosphorus. Phosphorus is have 15 electron. So the electron configuration is 1s2, 2s2, 2p6, 3s2, 3p3. Dan kita tahu kalau elemen tu located at period 3, dia ada empty D orbital. So kalau kita lukis diagram, okay, untuk 3p dia, dan dia punya 3D, okay, so 3D ada 5 box. So this 3 electron akan dalam 3p. Okay. So maknanya since we know that kalau kita kira total valence electron surrounding the phosphorus, okay, untuk this case total electron dia ada 10 electron. So ada 10 electron. So kita dah ada 3, so ada baki lagi 7. So sini kita boleh masukkan 1 electron. So and then the reminder okay, reminder tu kita boleh masukkan dalam kita punya 3D. Kita boleh masukkan dalam kita punya 3D electron. Okay, same goes kalau another example is SF6. Okay, SF6 kalau awak draw dia punya Lewis structure, okay, S will become the central atom. Okay, S become central atom, so we octet the terminal. Kita octetkan dia. So kalau kita kira, dia punya formal charge, each of the fluorine will have a formal charge equals to 0, and same goes with the sulfur. And for this case, the sulfur, the total number of valence electron for the sulfur is equals to 12 electron, which is greater than 8. Sebab apa? Sebab sulfur ini located in period 3, so maknanya sulfur ini ada empty 3D orbital. So the extra electron tu kita boleh isikan masuk dalam 3D orbital. That's why lah SF6, the sulfur can accommodate electron greater than 8 electron. Sebab apa? Sebab dia ada empty D orbital. Okay, and the last type for exception to octet rule is the odd number electron. Okay, so the odd number electron happen when the surrounding central atom have a total number of electron which equal to odd number. Okay, odd number macam 7, 9 and etc. And normally it happen when the central atom dia terletak dalam group yang ada odd number. So for example nitrogen and chlorine. Because nitrogen is located in group 15, so odd number. Chlorine is located in group 17, which is also odd number. So normally kalau central atom tu datang daripada group yang ada odd number, so dia akan form odd number electrons. Okay, so for example for a molecule with odd number electron is NO2. So if you calculate the total valence electron, okay, total valence electron dia, nitrogen is 5, okay, oxygen is 6 times 2. So awak akan dapat 17 electron. So the nitrogen will become the central atom. So awak dah guna 4 electron, so awak kena baki lagi 13. So awak isikan terminal, ada baki, awak dah guna 12, so ada baki lagi 1 elektron. So 1 elektron inilah yang awak akan letakkan dekat central atom. So kalau awak kira formal charge, the formal charge is still not stable. So nak stable kan, kita akan form satu bond. So the most stable structure for NO2 is this one. So this is the most stable structure. And then kalau awak calculate dia punya formal charge, okay, kalau awak calculate dia punya formal charge untuk oksigen ini adalah 6 minus, this one is minus 1, this one is 0, this one is 1 plus 3, 4, this one is positive 1. Okay, this one is positive 1. So, dia dah kira stable sebab kalau awak form lagi satu double bond, okay, kalau awak form lagi satu double bond antara this oxygen and this nitrogen, nitrogen ni akan ada higher formal charge. So, dah tak stable. So, kalau awak kira the total valence electron surrounding the nitrogen is 2, 4, 6, 7 valence electron, which is odd number. That's why lah NO2 ini kita panggil dia sebagai odd number electron. Sebab apa? Sebab the total valence electron surrounding the central atom does not equals to 8. Okay, and then dia punya ni adalah dalam bentuk odd number, nombor ganjil, which is 7. Okay, so now you already learn about the exception to octet rule. Okay, dan kita pergi resonance structure. Okay, resonance structure ini is basically, okay, is a structure, okay, if you have the compound, okay, the compound tu dia ada more than one Lewis structure. They are capable to explain, they are capable to explain the actual structure of the Lewis, of the molecule. Okay, so maknanya resonance structure ini adalah one or two or more Lewis structure for a species that cannot be adequately depicted by a single structure. Okay, so for example, kalau kita tengok NO3, kita tengok NO3 minus. Okay, so requirement for resonance structure, the first requirement is, okay, the structure itu must obey, okay, dia must obey either octet, duplet, expanded ataupun incomplete octet. So maknanya kalau stable structure dia octet, maknanya waktu awak nak buat resonance structure tu dia mesti obey octet. Okay, then the second requirement, the molecule or the ion, okay, before awak lukis Lewis structure tu must have at least one multiple bond. Okay, multiple bond ni adalah double bond ataupun triple bond, dan at least one lone pair electron at the terminal atom. Sebab dalam resonance structure ni kita akan gerakkan bond dengan lone pair tu, kita akan gerakkan dia. Okay, so for example NO3, okay, NO3, okay, the Lewis structure for NO3 is N double bond O, single bond O, single bond O. So yang ini macam kita dah belajar waktu kita lukis Lewis structure in lesson 2. Okay, let's say kalau saya labelkan this one is oxygen A, oxygen B, oxygen C. Okay, in order to draw the Lewis structure, we need to move the multiple bond and also move the lone pair electron. Okay, kalau saya salin balik, structure tu, so double bond O, single bond. Okay, make sure awak kena lukis dia punya bracket sebab dia adalah ion. Okay, so sebab awak tengok semua ni octet, so waktu awak buat resonance structure itu pun awak kena make sure everything is octet. Okay, kalau kita tengok pada permulaan dia, double bond ini located between nitrogen and also oxygen B. Okay, so sekarang ni saya boleh pindahkan double bond tu pergi antara nitrogen dengan oxygen A. Saya boleh juga lukis double bond tu dekat sini. Ataupun saya boleh pindahkan juga double bond tu pergi ke nitrogen C. Macam tu je lah cara ni kita nak lukis resonance structure. So mula-mula double bond tu antara nitrogen and oxygen B. So the second structure, saya tukarkan pula double bond tu between nitrogen and oxygen A. Saya tukarkan dia. So sini ada 4, sini jadi 6 lone pair lah, sebab kita kena make sure semua tu masih obey Octet Rule. So sini pun ada 6. So kita kena lukis dalam bracket sebab dia adalah ion. Dan macam saya cakap tadi, boleh juga double bond ini, okay, double bond ini saya pindahkan daripada nitrogen pergi ke oxygen C. Boleh juga. So maknanya nanti lukisan awak double bond tu akan pergi dekat sini. So sini single bond, sini pun single bond, sini double bond. Okay, awak kena make sure everything octet. Okay, since all these 3 Lewis structure are happen at the same time, are produced at the same time, kita kena lukis double headed arrow. Maknanya to represent the Lewis structure of NO3, the actual Lewis structure of NO3 minus ini adalah hasil gabungan, hasil combination structure 1, structure 2 and structure 3. Sebab kalau by theory, kita tahu waktu kita belajar first lesson dulu, single bond mesti akan lagi panjang daripada double bond, and double bond is longer than triple bond. So kalaulah NO3 minus ini hanya ada satu je Lewis structure, hanya satu, kita boleh expect bond antara nitrogen dengan oksigen B ini, bond antara nitrogen dan oksigen B ini lagi pendek daripada bond antara nitrogen dengan single bond oksigen dari A. Tapi kalau kita buat eksperimen, kita tengok bond dia, tak kisahlah dia antara nitrogen dengan oksigen mana, bond dia sama. So maknanya the actual Lewis structure for NO3 maknanya adalah hasil gabungan ketiga-tiga structure ni. So actual Lewis structure dia adalah, kalau kita nak lukis hasil gabungan dia, kita lukis single bond. So dotted line ni menunjukkan bahawa elektron dekat double bond itu sentiasa bergerak. So sometimes dia pergi bergerak ke oksigen ni, sometimes double bond tu akan berada di oksigen ni, sometimes double bond tu akan berada di oksigen yang ini. Ini kita panggil dia sebagai resonance structure, di mana one Lewis structure is not enough to adequately explain the actual structure of the molecule. So maknanya untuk NO3 minus, dia ada 3 Lewis structure yang kita boleh gunakan untuk represent the actual Lewis structure tu dan kita gabungkan dia. Okay. So ingat, nak lukis resonance structure, awak gerakkan je double bond tu dengan lone pair. Dengan lone pair tu as long as dia either obey octet, expanded ke incomplete ke ataupun duplex. So, tapi for this case, kita kena obey octet lah. Sebab nitrogen dan oksigen, especially dia tak ada exception to octet rule. Kalau kita lukis dia punya Lewis structure. Okay, so second example is HCO2 minus. Okay, second example is HCO2 minus. Okay, kalau awak lukis dia punya Lewis structure, carbon itu akan jadi dia punya central atom. Okay, dan Lewis structure dia adalah macam ni. So sini ada 2 lone pair, sini ada ni. So ingat dia ion, so kita kena lukis dia dalam bentuk bracket. Okay, ingat nak lukis resonance structure, kita hanya perlu gerakkan dia punya multiple bond dan gerakkan dia punya lone pair. So kita gerakkan, so ni tengok ni daripada carbon ini ke oksigen ni. Okay, double bond dia. Dan double bond dia juga kita boleh pindahkan daripada carbon ni ke oksigen yang ini. Okay, tapi kita tak boleh pindahkan ke hidrogen. Sebab apa? Hidrogen mesti duplex. Hidrogen tak boleh lebih daripada 2. Okay, so kita lukis lagi satu dia punya Lewis structure. So, sekarang ni double bond dia ada dekat oksigen yang tepi. Dia ada dekat oksigen tepi. So, kita lukis kita punya bracket. So, ini hanyalah possible Lewis structure. So, ini kita panggil resonance structure untuk HCO2 minus adalah macam ni. Sebab apa tak boleh double bond kat hidrogen? Sebab hidrogen hanya boleh duplex. Okay, I think that's all for today. So, in the next lesson, we're going to learn about the molecular geometry and also the molecular polarity of the molecule. Okay, I think that's all for today. So, okay, thank you everyone.